This is lesson 15 in our series of building Streamlit automation dashboard for predicting stock prices for the given list of stocks and 5 prediction models. Last session we completed the backfill daily prices file. Today we are going to start working on imports mainly for train predict py. So open your IDEs and make sure that you have train predict file created in scripts folder. What this file will do, let's have a high level overview of it. It will load historical stock price data from CSV files. It will engineer technical indicators and lag figures. It will train 5 models: linear regression, random forest, ARIMA, RNN based LSTM, and LSTM. So next, it will save trained models to a disk storage. In our case, it will be the folder, models folder in our project. Use model files to generate predictions for stock prices for the next trading day, and save predictions with historical error tricks, which are mean absolute error, mean squared error, and not root mean squared error, but mean absolute percent error. Remember those MAE, MSE, and MAPE. So, long story short, this will be a hybrid machine learning and time series forecasting pipeline. Now let's go with the imports. We are going to import pandas as PD, import numpy as NP. Pandas for tabular data, CSV and time series, and numpy for numerical arrays. As we are going to deal with files writing and reading, we will definitely need OS. Import joblib. OS, as I mentioned, for file system operations, and joblib for serialize and deserialize sklearn models efficiently. Next, we are going to import datetime, time delta. And one more thing, while we are doing this, please make sure not to get scared if any alarms or alerts will be posted here. We will fix them later on. Daytime we will be using for timestamp predictions and generate tomorrow's prediction price. As we are going to do some alarms or alerts or errors shown in the console, we will import logging. For typing hints and readability and ID support, from typing import list dict tuple optional, not tuple. Okay. Next, we are going to import warnings. And warnings, filter warnings, ignore. We are going to suppress warnings which which later on will be used in our code. So as we are saving possibility to use the environment variables such as API keys, etc., we are going to need from .env import load.env, write down load.env. For the information stored and normalization parameters for neural networks, we are going to use TensorFlow Keras layers. Import, from TensorFlow Keras layers. This we are going to use inside RNN and LSTM to stabilize their training. We are going to import JSON file for readability of structured data. And now let's move to model imports. From sklearn linear model, import linear regression. From sklearn ensemble, import random forest regressor. From sklearn preprocessing, import standard scaler. These are the classical ML models. And now let's move to other models. From stats models, TSA RIMA model, import RIMA. This is the time series forecasting model. Import TensorFlow STF from TensorFlow Keras models. Import sequential from TensorFlow. Actually, I guess we already did something with TensorFlow. No, not this one. out from TensorFlow search import them. All three of these are our deep learning stack components. From sklearn metrics, import mean, absolute error, mean, squared error, and mean absolute percentage error. These are our evaluation metrics. I guess this is it for the imports. Now we configure logging. Logging basic config. Level will be info. Format as time, name, level name, and messages. Last one for today, logging So to summarize our activities for today, we created a file, we added what we are expecting of this file to do, and we started imports. Next, as you can see from IDE hinting what we are going to do, we will create class of stock prediction. We will create initializer. This is it for lesson 15. See you at lesson 16. Bye-bye.